Okay, so we've got firmware written, and everything seems to be behaving as expected. Challenge number 3 was reversed LED. You probably can't see on camera, but when I pop over to the microscope view, we can see that that LED is lit. And then number 13 is the one that was reworked yesterday, the one under the BGA site. And that one is also detecting as good. All the others are failing as expected because we haven't started them. So, before we do anything else, I'm going to unplug the board and get ready to do some more poking at it. So here's the current status. We've got another, 14 challenges to work on, and just have to figure out which ones to do first. I'm thinking it probably makes sense to do the 2 on the spy flash, and then while we're in that same general area, probably populating the 0201 and the 0105. That's challenges 4 and 5. So those should be pretty simple. Let's actually do those first, just as a nice, easy warm-up. Here we go. So yeah, here we go. We're on the polarizer. So this is the spy flash, and we can see right here, we've got one pad that is lifted and just a hole there, and one pad buried under solder mask. And then over here, we've got an 0201 and an 0105 that are unpopulated. So those are just kind of the warm-ups. I think those are like 100 or 200 point problems. And then actually in the same area, maybe even before we do those, we also have challenges 1 and 2 are a pair of shorts. So challenge 1 we can see is this tiny little short here, and then challenge 2 is the longer short there. So let's actually do those. Challenge 1 should be a pretty quick one. So I'm going to try and clear that one with the scalpel and see how difficult that is. Let me just get some of this junk off of the blade. Maybe almost time for a new blade on this thing. It looks like it's got some debris attached. Alright, so this is a little bit of an annoying angle with the BGA on one side and the flash on the other side. It may almost make more sense to pull the... I can't get the scalpel in at a steeper angle because the flash is in the way. I'm actually going to switch to the number 16 blade instead of the number 11. That has a kind of a hook tip that might be better for getting in this tight spot. And the blade's a little bit yucky. Alright, let's get a new blade, and then... Alright, sorry, I misspoke. Number 12, not number 16. So let's go take old blade and toss it, and get a new number 12 blade. I think that's better for getting in these tight spots. Picking the right blade is a bit of a art and something that people don't talk about a lot in rework. A lot of people just use like X-Acto knives and stuff like that. I've found surgical blades are much better. You get a big range of sizes and shapes, and they also tend to be just sharper and better quality, and they don't have like oil residue on them and stuff like that. And so for something like this, we want to come in from a bit of an angle. This is pretty fine pitch, so it's going to be a little bit tricky. So what we're trying to do is clear that and come in like that. And actually, I'm going to switch this upside down. Come in this way. And go in the other direction. Make sure the camera is actually showing the area I'm working, because my field of view through the eyepiece is wider than what the camera sees, and so I want to make sure that you're seeing the important part. I'm actually going to swap the So we're kind of trying to create like a V-shaped groove here where we're cutting it from both sides. So we got the solder mask out, we still have the metal. And let's not lose that little bit of copper that is causing a short. We don't want that to go somewhere else and short something else, so just pick that up. Okay, so now the short should be cleared, and I'm just going to try and polish this a little bit more, make sure I get as much clearance as I can and don't thin the traces too much. I really prefer the number 11 blades for this, but in these tight quarters, the 12 does let you get just a little bit more of a vertical angle in. Alright, so short is gone. We only nicked the solder mask in one spot, and it looks like we pretty much haven't majorly thinned down the tracks too much. So I'm pretty happy with that. Before we go any further, I'm just going to zoom out, and we're going to apply power, and we're going to see if it is happy. That was challenge number 1 that we just did. All right, and challenge 1 lights up as complete, so we're good. That one is successful. I am going to touch up some solder mask around there afterwards just to get the area a little bit more professional and cleaned up, but I don't want to be doing that for every single edit that I do. It makes more sense to do a couple at a time. So I'm probably going to do 1 and 2 and then touch up a solder mask and then do everything else around it. Because what I want to avoid is once I start doing rework in an area, if I'm going to start soldering around it, I want to do any coating work that I'm going to be doing first, because once you have solder flux in an area, it will cause adhesion problems if you try to put coatings on afterwards. And so, yeah, you can remove the flux, but it's easier if you just do it before the flux gets there in the first place. And so, plan is going to be, we've finished 1 electrically. We're going to verify, we have verified 1 electrically. We're going to do 2. We're going to verify 2 is good. Then do the coating touch up on those. And then there was an area on the back side that was just a solder mask repair problem as well. So try and do all of those in one go, get all the solder mask work done together, and then go back, and then I'll have to check, challenge 3 was the backwards LED, we did that one already. So that'll be 1, 2, 3 done, and then if we're just gonna start doing them in numerical order, that'll be 4 and 5 are the 0201 and the 01005 up here, and we can do those next. All right, so now, challenge 1 was the really tiny little blob short here. That is simulating like a dust speck on a photo mask or something like that. Now we're up to challenge 2. This is also a short, but we can see it's much longer, and so this is kind of simulating like an etch defect or something like that. And so this is going to be a little bit more challenging. It is a, I believe, 125 micron gap between these tracks, which is pretty fine pitch. My normal end mills are actually 250 microns. I do have some hundreds. It would be possible to do this on the mill, but the 100 micron end mills are really fragile and break really easily. Plus, it's not super accessible to a lot of people. So I'm going to try and do this the old-fashioned way with a scalpel, and if I screw it up too bad, I can always patch it up and just go do surface tracks over it. So let's see. Trying to just keep this nice and straight. And let me grab the ultra-fine tweezers here again. Whenever you're removing pieces of copper, it's very important to keep track of them and know where they're going so that you don't create new shorts somewhere else when they go flying. So I'm going to grab my ultra-fine tweezers here and just pick up that piece and make sure I know where it's going. And actually, let me just get a piece of Kapton tape here. So I've got something to stick it to. That was a little trick that I learned when working on wire bonders a while back, is if you ever have chunks of conductive debris that you just need to make go away and you want to know where they're going and not have like chunks of tiny gold wire sitting around shorting things, just get some upside down tape and stick it on something, and that way you've got an easy surface. You can just go kind of touch your tweezers to it and anything stuck to them will adhere. And then you don't have random conductive debris contaminating the rest of your system. Alright, so same idea, just kind of trying to do little, maybe, I don't know, 0.5 millimeter or however long these sections are, and do kind of a V-score from both sides, make sure we get a nice undercutting of the track, and then come in with the tweezers and get the loose piece of copper out of the way. I might have to actually poke that with the blade and get that free again. Nice and slow, make sure we know where the copper piece is so it doesn't go flying. That should be sticking out enough we can grab it. There we go. Just kind of rock it back and forth a couple times until it snaps off. Alright, and that's about halfway through this area. I'm just going to actually come in with a swab, and there's a bunch of finer debris I want to get out. Cleanliness is vitally important when doing this sort of work. Again, you do not want small copper debris getting around and shorting things, so if you ever see any loose debris, deal with it immediately, don't wait. Plus, getting all the solder mask shards and everything out of the way just makes it easier to see what's going on. Alright, so now coming in again, trying to keep that same V groove. Takes a decent amount of pressure, more than you'd think. And then as soon as we've got the groove, we come in from the other side and just try to widen it a little bit. And just for scale, these are 125 micron, or I believe 5 mil in Freedom units tracks. You definitely could do this on smaller with some practice. It would be a little bit trickier, but absolutely possible. Alright, we got another loose piece of copper here. Let's clean that up. coming up on the end. Just making one last pass down the whole trench to make sure it's cleared. We did thin that a little bit more than I wanted to, but again, these are not impedance controlled tracks, so having your 125 micron track jump down to 100 or so is not going to break anything. But for practice's sake, I am trying to get the geometry as close as I can to the original. Alright, and then we just got one tiny little gap down near the very bottom right here. Just going to go a little further than I need to into there, and we are... Alright, so definitely clear now. Get that one piece out of the way. So that was IPA, and then just follow up with some acetone to make sure we get everything. The acetone also evaporates quicker, and so we don't have to worry as much about leaving residue. Some components are obviously going to be sensitive to it, but the solder mask, it shouldn't hurt. Okay. So, visually it looks good. I don't see any shorting. We've got just a little bit of raised burr on the edge of the trace there on the right. I'm going to try and see if I can clean that out. Probably going to want to come in from the top and just kind of see if I can... that angle is a little tricky. Maybe I want to come in like this. Yeah, the burr doesn't seem like it's high enough to be a problem. Alright, so I think we've got full isolation between these tracks now. So let's go and get the tape out of the way. And hook power up, and confirm challenges 1, 2, and 3 are now passing. That is exactly what we wanted. Also good to know my grader firmware is working, because this is the first time I've tested it. I didn't have a previously reworked board that I could test the grading code on. Alright, so what we're at now is we've reworked challenges 1 and 2. 3 is already done. 4 and 5 are going to involve soldering right here, and that's going to add flux. And again, we're trying to avoid having surface contamination on here that's going to interfere with coating adhesion. And so we got to do that. And then on the back side, we've also got, I'm going to want to do some cleanup first, but I've got challenge SM1 is a solder mask touch-up in that area. So I'm going to go and just get some... yeah, I'll just use IPA and acetone again. I'm not going to pull out the fancy stuff. I do have some fancy flux remover that I use for when I want to clean, like baked on, no clean flux and stuff. Electrolube Safe Wash Super. but it is aqueous. It takes a while to dry afterwards, and so if I'm just trying to remove stuff from the area of where I'm going to be doing rework, usually I'll just do solvent cleaning, unless, again, if there is baked on no clean flux in the area that's gone through a reflow cycle, then I will go and pull out the strong stuff. But it's overkill for this, and the solvents dry faster, and it's fine for what I'm doing here. So what we're just trying to do is, we don't care as much about surrounding surface stuff. We just want to make sure right around the area of the rework, we have absolutely nothing on there that's going to interfere with adhesion of the coating. And so I think what I'm going to do is do this open area first, cure it, and then flip over to the front side. Okay, so we're done soldering for a bit. We can turn off that fan. That's going to cut down a bit on the background noise. And let me grab the solder mask replacement. Oops, forgot to change camera angles. All right, so this is just a random AliExpress or Amazon or something solder mask kit that I haven't used before. I have some other UV Cure solder mask. It's older. I wanted to give this stuff a try. And so we're going to see how it performs. It looks like it is in a clear syringe, which I'm not thrilled about, given obviously ambient light around here. So what I might actually do is transfer some of this to a somewhat UV opaque syringe, and that'll also make it easier to dispense, because right now these do not have any plungers in them. So I'm just going to stick those two in the fume hood real quick. Get my bin of there we go. So get my bin of UV blocking syringes, and we're just going to repackage this. And that'll also make it easier to dispense later on. Lure lock couplers. This is going to be a closed system transfer. There shouldn't be much stinky leakage or anything like that. I'm doing it in the fume hood is mostly just for containing the mess. I'm not too concerned about vapors or anything like that. But hey, I got a fume hood. It's an easy to clean area, and it is about the only unoccupied large flat surface in the lab right now. So it kind of becomes my general messy wet processing space. Okay, so let's go get the plungers here and assemble the two new syringes. Get the couplers on. And I will need to find something to hit the backs of these, because they don't have plungers on them. What I've done in the past has usually been to grab like a random 3/8 inch bolt that I have lying around in the parts cabinet. I've usually improvised these as plungers, so let's see how well that works. And yeah, everybody should have a fume hood. I mean, I've fixed so many of my kids' toys in the hood just because I didn't want to have the glue sticking up the house. And like, yeah, sure, would I have done it outside or whatever if I didn't have one? Yeah, but hey, I got a fume hood, why not use it? All right, so that is our red solder mask. And we'll cap up the original. Oh, I forgot to get caps. Let me do that. At some point, I got to go set up like a portable camera or something that I can use to show the storage cabinet in a little bit more detail when I'm fetching stuff or whatever, because right now I don't have a good camera angle on that. The images you're seeing from overhead are actually just security cameras that double as streaming cameras because I've got them already. That was not what I set them up for, so they're not necessarily optimized for the most photogenic views. They're optimized for good field of views and be able to see everything in the lab to some extent, but alright, we're going to say that's probably good, and that bolt is still clean. Alright, so that's done. Coupler comes off. Cap that. These can now go back in the cabinet in the solder mask bin. And the syringe bin goes away. Alright, so let's label these. Through the UV blocking syringes, it can be a little bit hard to tell what color everything is, so I'm just going to label them just so I know those are red and those are blue. Whoops. Helps if I actually hit the right letters. Alright, that's more like it. So one of the open questions I have is how I want to actually apply this for the purposes of dispensing and mixing. If I'm trying to do a color blend, if I was just trying to do a single color, it would be more straightforward. So I'm going to try and dispense a little bit into this plastic cup and kind of stir it together and see how that works. Before I do anything else, let me actually get my lab coat on. The UV curing lamp is pretty strong, and I try not to have any exposed skin while I'm working with it. Hopefully this isn't too loud while I'm moving the mic to clip here. There we go. Okay. These can come off and get these ready. These are actually laser rated eyewear that I wear when I'm using the strong UV curing lamp. They're perhaps slight overkill, but it dumps something like a watt of 365 nanometer into a couple of square millimeters, and I generally treat it with the same precautions that I would a strong laser source. It happens to not be coherent, but I really don't feel like going snowblind or sunburned or whatever else strong UV sources do to you, so no exposed skin and eye protection anytime I'm working with it. Alright, so these are just 20 gauge needles here that I'm putting on, and let's actually just separate these so I remember which is which. I also have no idea what the actual curing profile of this solder mask is as far as how long it's going to take to cure, how much of a UV dose I need or anything. So this is going to be a bit of an experiment, but that's why I'm doing it on a practice board. I know it's something I care more about. And who knows also how close the color match I get is going to be. This is very much a experiment. So I'm going to try a little bit less blue than red. And I got some on the bench. This is lower viscosity than some of the stuff I'm used to dealing with. Let me clean that up before it dries. Alright, so just mix this up with a little wooden toothpick and see how purple it looks. I'm sure it's not going to be the exact color match. If this was like a mass production and I was doing a whole bunch of boards, I'd be able to put more effort into getting the color perfect. This looks a little bit too dark. Let's go add a little bit more red. Alright, this might be a little bit too red, but it's purplish. And yeah, these are like $200 laser rated safety goggles. Again, probably overkill for a non-coherent light source, but the stuff that came with it didn't have any specific rating, and these are like optical density 6 at 365 nanometer or something in that range, 5 or 6, I forget. Either way, more than enough attenuation for something that's not a laser, so. Alright, so plan is I'm just going to kind of blob the solder mask on here. With this stick. And yeah, a third of the price actually sounds about right. I want to say the UV system was around, I don't know, low 4 digits, and the goggles were like $200-300 or something like that. They're not cheap, but yeah, the alternative is worse. It looks like our mixing is a little bit off here also. I can see some sections that are a little bit bluer. I'm just going to try to smooth this around and get the color uniform. Alright, that's probably enough of a spread. Again, if we really wanted to, we could go back and forth and mix and match the coloration and try and dial it in tighter, but that's probably close enough. So I'm just going to do maybe 15 seconds with this and see if that's enough to cure it, and go from there. Alright, goggle up, power to 100%. And this is the system if anybody's curious about it. I'll try and put the, I don't know if you can read the Thorlabs part number on there. But yeah, this is a serious UV source. All right, gloves on, lab coat on, goggles on. Let's hit it. Let's actually, let me switch cameras. Can we move this? That one's about as far as it'll go. All right, yeah, the long shot is probably better for this. And the other thing I'm watching is, as I'm working here, paying attention to where the scattered UV is going, because I don't want to be curing the stock container of solder mask or like plugging up the needles or anything like that. I want to make sure I'm not illuminating any of those by accident. Some of the UV curing materials I use are actually sensitive enough to visible light that just working under the microscope for a while will cure them. And so I will have to like start building up a section of stuff I'm gluing together, and every minute or two swap needles because the microscope illuminator was strong enough to make it solidify. Alright, so I think that should have been enough. Again, I'm just guessing. I don't know how much it takes to cure this, but it looks like the texture has changed. So let me go get one of these swabs and just kind of poke it with the back of it and see. Yep, I mean, the surface being very slightly tacky is expected for a little bit. There's usually a little solvent that doesn't fully evaporate or something, but yeah, that doesn't look like it's going to go anywhere. All right, I'm going to call SM2 done. And now we can switch over to the front side, and focus is just going to be on touching up the area right here around challenges 1 and 2. That's probably enough already. Just trying to make sure we don't have any exposed copper that's going to corrode. I'm not too concerned about covering that silk screen. That was kind of to be expected here. And also make sure we're not covering anything conductive that we care about. So that should be good. And if anybody's wondering, you absolutely do not need such a fancy UV source. I've seen just like mercury vapor mineral lamps or LED gel curing nail thingies. The difference is that this puts out way more power, and so it turns what would be like a 5-minute cure cycle into a couple of seconds. So if you're doing this kind of stuff professionally, having the high power source is a big help. If you are a hobbyist or a small shop and you're not doing it often enough for the time savings to be important, then you can definitely save a lot by not doing that. Okay, that is it for there. Let's go clean up this goopy syringe mess here. We're done solder masking for at least the next couple minutes. All of that is garbage. Those can go back in the solder mask bin. One thing I will need to do a little bit later on, there is a silk screen touch-up, so I will have to, I forgot to put the white solder mask in the tube. When I repackaged the blue and the red, I forgot to do the white, so I'm going to have to go back to the hood and do that in a couple minutes, but we don't have to do the solder mask one right now. Or the silk screen one right now, sorry. Alright, and yeah, I'll just keep the lab coat on so I don't have to move the mic around too much. Clean a few more bits off the bench. Get that out of the way. Okay, so that is challenges 1 through 4 now complete. and, or sorry, 1 through 3. Now we got 4 and 5. Going over to, yeah, let's stay here on this view for a second. Here we go. Okay, so 4 and 5 are putting a 0201 and 01005 resistors down. Right now, because the stencil had apertures for these, there is solder paste, or there is solder on the pads. That might be a little bit tricky. All right, let's think about how this is going to go. So right now, if we put it on with an iron, it's going to be kind of tilted up. What I might end up doing is I might tack one end down, tack the other end down, and then hit it with hot air. That might be easier than trying to clean the stuff off of there. Let's just fit test with the iron off. Let's just see how big the tip is in comparison. So this is a 100 micron radius, I think, conical tip, although it looks like it may have blunted slightly. I may have poked it into something or whatever, but yeah, this is a nominal 100 micron radius conical tip. And so hitting that is going to be a little tricky. I can do it. The 0201 should be easy. I have not done an 0105 in a long time. Let's start with the 0201 and see how it goes. So fume extraction on, mini iron on. We definitely are not going to need the full-sized iron. Get some flux in the general area. There is no precision at these scales for flux. Just flood the area and clean up the extra later. Alright, so let's do the 0402 first. Or sorry, the 0201 first. Oh, and also I still have the little bin of solder mask. I'm just going to put, oh, there we go. I'm just going to put a stencil over the top of it. It's opaque enough. It'll hopefully keep the ambient light from curing it, and later on, if we still need it, it may still be good. Alright, so there's the 0201. And it's upside down already. These are 10 by 50 micron point tweezers for scale. I think that's a little outside the frame, but yeah, I had to flip it over. Okay, so yeah, plan I think is going to be come in from the bottom position, although I'm going to rotate the board just to make it a little easier. So I'm going to come in from what's now the right side, holding the part from that side, have the iron between the component and the BGA. I think that'll be the easier angle to approach from. I'm left-handed, and I usually prefer to hold the iron in my dominant hand when doing this sort of stuff, so I'm going to try and set things up so I'm holding the component in my right hand and the iron in my left. Alright. So now we're sitting up there on top of the blob of solder, and now let's hit it with hot air and see if we can get it to self-center a little bit more. The footprint that I'm using here is like an IPC least-sized footprint. Also, I'm going to move down a little bit because I think I was on the edge of the frame here. So we're going to let the hot air warm up a touch and then do that, and probably get this one in position before I do the 0105, just so I don't have to try and do both at once. So hot air coming from, this is the bottom side, probably just outside of frame. I can see it in the microscope view. And we're just trying to reflow this part and get it to gotta be almost time. See the 0105 pads melting. The vias are just heat sinking a little bit. There we go, it just settled into position. Okay. So that's the 201 done. Now we got to do the 105. Let's get a little more flux on there, now that we blew a bunch of it away. And that was the 201, now the 105. Even just picking up 0105s by hand is a challenge. If you've worked with like 0402s and even 0201s, they're absurdly tiny. Again, for scale, those PCB traces that I'm working around are 125 microns. Alright. That's the 105 off the tape, and gotta make sure I don't let it out of my sight because I might not find it again. These tweezers are going to need a cleaning afterwards. They've got flux on them. And yeah, that's one of the points of this board, is just to have something to practice with. I probably should have put more 0201 and 0105 footprints on here in the free play area. I think everything's 402. So maybe if I do another revision or something, I'll put some 201 and 105 footprints in there just so people can get a chance to practice. Personally, I prefer to avoid working with parts this small. 99% of my designs, the smallest thing is 402, and like all my decoupling caps and everything are 402. I recently did a board with a few 0201s on it. I've never used an 0105 on anything but a practice board. And I think it's actually my first time hand soldering an 0105. I think I reflowed one a couple of years ago just to see if I could. Alright, and now let's just hot air that and make sure that is fully in position. If you ever have hand soldering that's not super perfect because of awkward angles or anything like that, just hitting it with hot air usually does a good job of cleaning it up. Starting to melt. I think I might need a little more flux on the one side of it. I don't know if I didn't heat enough or if there is you know, I think I can clean that up with the iron now. Yep. Perfect. All right, that's good enough. Okay, I think that's it for the moment, and now I can go clean the flux off of the tweezers. A significant fraction of my swabs are probably used just cleaning flux residue off of tools after use, but if you don't clean them well, they get sticky at the most annoying moments. So, and Just make sure I didn't... Yep, that looks good. Alright, so let's clean the surrounding area here. That should be... Actually, I'm going to leave the hot air on because the next challenge is going to need hot air too. Alright, so let's clean the flux off around here. And that was 4 and 5. I'm going to go back to the overview shot. Give the board just a minute or so to cool down before I try to... actually, no, I can touch the microcontroller without discomfort. I'm not worried about it malfunctioning. All right. That is 1 through 5 are now happy. So that is exactly what we wanted. Successful on those. Now we're up for 6 and 7. So for 6 and 7, those are the soy flash here. We have the lifted pad on one pin and the solder mask residue on the other one. So let's hot air the part off, clean the pads, and then figure out a plan of attack. I'm going to lift from that side first because that's the one that's got less pins. Should come off pretty smoothly. Perfect. Alright, so now we've got the flash removed. We've got a bunch of solder residue on the pads that's going to have to come off so we've got space to work, and so it'll be easier to put on afterwards. Done with the ultrafine tweezers for the moment. And I'm going to actually want the big iron for this, not the small one. So flux all over here. The braid that I'm using is either unfluxed or doesn't have much flux on it, so I always add my own. And actually, before I do anything else, I'm going to go grab that Loctite adhesive out of the cabinet, or out of the fridge again, and let it start warming up, because I think I'm going to be using it a little bit later on. It's a small syringe. It shouldn't take long to come up to temperature, but... let's see, what do I got? Trace bonding and yeah, 22 gauge. Okay, so we still have a bunch of residue here. Let's clean a little more thoroughly on the surrounding area. The acetone really does a good job getting the last bits of flux residue off. It's just a little bit aggressive for some stuff you may have in the surroundings. All right. So IPA done, acetone done, okay. And so the first pads on the left side are all fine. The pads on the right side are all fine. What we need to do is get the solder mask off of this pad. Is straightforward. And then up here, we need to go put a new pad in and then connect it to this piece of trace here. So we need that little section of trace there as well. So for this, I'm going to use the hand scraping tool. This is what I tried to use under the BGA site, and the via was just too fragile because it was over drilled and there wasn't enough annular ring. Here, we're not anywhere near vias, so it works great. Circuit Medic sells this tool for like 10 bucks or something like that. A lot of the Circuit Medic stuff is overpriced, and I don't recommend buying it. Like, the little plastic mixing cups are literally like ketchup cups from a fast food restaurant. They sell them for some inflated price. The toothpicks, the little flag-shaped toothpicks, again, they sell for ridiculous prices, and you can just go to any restaurant supplier or Amazon or whatever and get those cheap. That being said, this scraper I have not found the OEM for, and Circuit Medic sells it for like 10 bucks, and that's a good enough price. If you want one, get it from them. It's not worth shopping elsewhere. That said, it is very likely it's some kind of dental tool or something. I would be surprised if it was something that they custom designed in-house. Get all the debris out of here. And looks now we got to clean just that one section off on the edge of the pad here, so we make sure we get a good fillet everywhere. And then also scrape here so we got something to connect our pad to. Alright, and done with the scraper for the moment. And, well, probably want to move that out of the way or something so you can see up there. And sorry if the focus is just slightly blurry. The microscope and the camera are not 100% parfocal, so if I focus for my eyes, there's just an ever so slight blur in the microscope, or in the camera view, and vice versa. Okay, so let's see. All right, so I think we're good here. All we got to do is put a new pad in on the missing spot for challenge 7, and challenge 6 should be ready to go as soon as we put the flash chip back on. So for this, I'm going to go back to the bench. Actually, no. Let's not drop these guys. Okay, so I got a big collection of these circuit frames. This is one of the things that I think Circuit Medic does make in-house, that I believe they're the sole supplier for here. And so these are essentially pre-cut pads etched out of copper foil of various sizes. I got a bunch of different ones here, and so I'm just going to poke through them and find which one looks like it's about the right size. This one has the film adhesive. I don't want that one. I have some that have a dry film adhesive backing and others that do not. I'm looking for the ones that do not have the adhesive. I do not like the adhesive that they provide on there. I prefer to use my own. I found it kind of gets goopy. So now the question is, which size do I want? Just kind of eyeing it. I think Those are a little bit big. The next size down. Are those the next size down? What about these? Those are a little bit short. They're almost perfect, actually. Yeah, I'll use one of those. So for these, what I usually do is I just kind of hold the frame still on the backing over the stick vise and cut it with a scalpel while I'm working. So we want the pad cut flush on one side, and we want a little bit of trace coming off the other. So let's do it like that. Probably should have gone to this view. These are tricky to pick up. I'm actually going to put the scalpel back under it and see if I can kind of scoop it up with the scalpel. These are like 30 micron copper foil here that I'm trying to pick up without damaging, so. And you can see one side of it is plated and the other side is bare. Alright. This is one of those parts, like I mentioned earlier, that I have not found any substitute for that I believe are custom made. I'm sure there are other vendors. I'm not saying Circuit Medic is the only place who makes them, but that's who I've used for this sort of stuff. And again, I'm not aware of any good alternative for this sort of work. Okay, so just clear some tools out of the way. Make sure I keep sight of where that pad is. So I've got the pad here. That looks almost perfect, actually. So for attaching it, what I'm going to do is this, and I think that's sticking out too far, but that should be okay. Actually, I think it might be a little bit large. Okay, yeah, no, it's just too tall. I'm going to have to shrink it. So for this, I'm just going to come in with the scalpel from the top and just kind of rock it a little bit. Let's see how that looks. It probably needs a similar cut on the other side. Yep, still just a tiny bit too tall in the other direction. Again, just kind of rock the blade up and down, and it cuts right through. This is where the surgical blades really beat and with like the cheap X-Acto knives or anything like that. I gotta dump my bench trash here. It's getting a little bit full. Alright, so there's the pad here, and that fits perfectly, except I gotta cut the track a little short as well. Let's do like that. Alright, so there's our new tinned pad. Fits perfectly, and we've got enough of a tail we can solder to. Alright, so now all we got to do is get just a tiny bit of adhesive in under it, press it in place, and cure it. Let me get some gloves so I don't get glue on my hands. Again, looks like the CAD view is kind of blocking things, so let's move that off in the corner. Actually, I'm just going to turn that off. It's not useful for what we're doing right now. So we're using that same Loctite adhesive from yesterday. I'm just trying to get the tiniest amount under. Even that's probably more than we need. And I'm going to use one of these little wire needles to poke it into place and spread it around and try and make sure. What we're trying to avoid is having anything unadhered on the edges that might create a stress concentration point that could cause it to lift in the future. That's probably good for now. Put the pad in place and align it. That looks good. It's sticking up a tiny bit over there. It's probably as flat as I'm going to get it right now. And I'm going to try to cure this with hot air rather than running through the oven. It's going to be faster. I just have to be careful not to overheat it too much. But one of the nice things about this adhesive is it is a relatively rapid thermoset. So if it gets up to soldering temperatures, it should pretty much be good to go. It's actually designed to be cured by running through a normal reflow cycle. I just do the 100C curing for my stuff because it's a little less aggressive and it puts less stress on the chips and such. So that's probably enough to cure it. I'm just going to get the scalpel real quick and poke it and see if it moves around. Alright, no, that was not enough to cure it. Alright, let's cook it a little more. Yeah, Alright, that I think did it. I saw it flash from dull to shiny when the tinning on the surface melted. So that should have meant it got hot enough to solidify. And even that might need a little more time. I still saw it move. Let's hold it at melting for a couple of seconds. I think it might just be the thermal mass of the PCB. I'm heating the surface and not necessarily deeper in. 1, 2, 3, 4, 5. Okay, yeah, that's definitely got to be enough. You can see the plating got a little bit dull from oxidation. Yeah, okay, that's solidly attached now. Let me get this other needle on the sharp spin before I poke something with it. So now we can go add some flux right around that junction. We're done with hot air for the moment, so that can go off. Done with gloves for a bit. Let's get the scalpel away. And I need the fine pitch solder here. Alright, so we're tinning the pad, but it looks like the trace is not pinning. I might have to scrape back a little bit more to get a good connection on there. So back to the scraper. Get just a little more of the trace length cleared. That should let us get better thermal contact with it. The bare copper can be a little bit tricky, just as far as thermal contact goes, and like it oxidizes more readily, so you need to be a little bit more aggressive. Same thing here. I'm gonna have to tin this pad a little more aggressively because it is now bare copper and it's oxidized a little bit from the heating around it. So actually, let me go do that one while I'm in here, and then I'll go back and do the other one. Oxidized copper is a pain to solder, so you need to sometimes even scrape it up a little bit to get the so let's let the flux do its thing. Yeah, wow, that is oxidizing bad. Drench the whole area in flux. Hope I don't need to get more active flux for this. The flux is like pulling away from the copper. That's weird. I'm not used to seeing that. Let me tin the iron again. Because that really looks like the flux is like pulling back from the copper. Does not want to go on it. Maybe hot air in this area might actually work better, just because it'll heat the whole surroundings. Let's do that, even though I just shut the hot air off. Because ultimately, I think what we just want is we want the whole soldering to be completely under flux and not exposed to air. I can also try, like, blowing nitrogen over the area or something while I work, but... Alright, yeah, we're at reflow temperatures. Still oxidation issues. And well, I think what happened was the oxidation occurred when I was heating the area to cure the adhesive. So I'm going to do one more try, and if this doesn't work, I may have to do some more scraping. Okay, yeah, I'm going to have to do something a little bit different. Yes, tin solder wick actually was something I was considering. It's worth a try. See if we can get a little abrasion in there. Alright, so let's try again. Drown the area in flux. Get some braid. Flux on the braid. Really, we just want to get that CU3SN or CU6SN5 intermetallic layer to form. As soon as we get that intermetallic layer, we're golden. I mean, we've got good tinning over the majority of the pad. It's just the very edges aren't great. That's probably enough to get a good connection, even if we have bad wetting. And then we still want to make sure we've got a good connection there on challenge number 7. Let's go add a little more solder here. Alright, I'm going to say that's probably going to work. Not the prettiest, but it's going to work. So what I can do now is get the flash chip, double check polarity. And yeah, solder does not like discontinuities. Trying to make a nice continuous surface is one of the more challenging things in this kind of rework. I mean, obviously it's better if it's a single solid piece of copper, but in a repair you often don't have that option, so your goal is just to get as close as you can. And like if we have serious concerns about the one pad for challenge 7, it is always possible that we could just go add a jumper directly from the top of the solder or something down to the pad, or down to the wire. I don't think that'll be necessary, but alright, I think we've got good connection now. Yep, let's go clean this up and see how it looks after a bit of scrubbing. IPA. And I mean, there's going to be more bodging in the same area, so any flux we clean is going to be replaced by more soon, but I at least want to be able to inspect the work and, again, not mess with coating adhesion or anything. Alright, and one more cleaning pass should be enough to get a good look at how we are. Yeah, that looks like it'll get the job done. Let's test. It helps if I actually connect the UART to it as well as power, doesn't it? I got a photo here just so I can double check I got the pinouts correct. Alright, I want gray, blue, purple. Alright, did I get that wrong? Gray, blue, purple. Okay, there we go. For some reason I had to jiggle it a couple of times to get a result. And yes, it is the populated board. I pulled the flash. So 1, 2, 3 looks good, and now we're seeing the flash chip. That is the correct part. It's able to interface with it. Given that the pins we were reworking were the read data and write data, obviously we've got good continuity through them. So now challenges 6 and 7 are good, and we're up to 8 is the next one we haven't done yet. So let's go check what challenge number 8 is. We may not necessarily do these all in order, depending on if I can do a couple together or something like that. Okay, so challenge 8 is a short section of tray gouged out. That looks like it'll be easy to fix. Just got to figure out. Oh, here it is. I actually should have done that. Right here, that's challenge number 8. That should go quick. I should have done that when I was doing all of the other soldering in this area with the 0201s and stuff. I actually forgot about it. Alright, that should be a lot more wire than we need, but it's there. And same deal, being left-handed, I'm going to try and come in like this so I can get the iron. The closer spot to BGA is going to be the harder one. So I'm going to do that first. Get in over there, flux on both, and try and tin the traces before I put the wire in place. This time we have not done any high temperature processing in the area, so it should tin a lot easier. But this kind of stuff is always a little dicey at times. The other thing that I'm going to do is I'm going to tin the end of the copper trace. So the joint that we're trying to create here is going to be between the top of the board and the bottom of the repair trace. So I'm going to take the new trace and I'm going to flip it upside down. So we've got it there. And then actually use the big iron to get better heat transfer. And then down here. And we're going to want just a little bit more solder on that other end. Again, solder on top is not doing any good. We're trying to get solder to wick in, around, and under to really make the best joint. And now we can go and cut off the excess about here. And that should be enough that we can get a nice butt joint at the end as well. In the little iron now. It's getting a little oxidized. This is the back side of the scalpel blade I'm just using to apply downward pressure to hold the wire in place as I work. Well, I've definitely done prettier work, but it looks like it'll hold. There's a little pointy solder bit there I don't like. Alright, we'll call that good. And then just have to get all of the flux away from here before we electrical test. Alright, so that was challenge number, what is that? 8 that we just did. And channel 8 is happy. Problem 8 is happy. Over here. Alright. So let's go look at what 9 is. Okay, I'm gonna go shut down the irons and a bunch of other stuff because channel 9, or problem 9 is a interlayer differential pair swap. So that is going to be quite the change and not require much soldering for a while. So I'm going to go do some cleanup here. Alright, so yeah, let's go get everything I was using for the previous couple of things tidied up. There's going to be a bunch of milling to do before anything else. Clean the tweezers. Clean the scalpel. That's done. That's going to go back in the fridge. And done with the fine pitch solder, and the IPA can go. And that's garbage. And okay, so we're now ready to go mount things up on the mill for the next round. And all right, so that is the interlayer differential pair swap that's going to come from the backside. Okay, so let's look under the microscope real quick before we do anything else, just to show the plan for what's coming. So we're looking from the backside up here. We've got this area for challenge 9 helpfully marked, and going to the CAD view here. So we're looking from the top down, and then jumping to the flipped view looking up from the backside. We have let's get my bearings here. Okay, here we go. So this is, we're looking at the back layer now in blue is challenge number 9. And then going up to inner 2 here, this is the N and P for the differential pair, and it just kind of loops around. And for the purposes of the challenge, we have to go and do the edit somewhere in this box marked on the silk screen. So if we just hide all of the other layers, this is the geometry that we care about. Let's get the all right, there we go. So this is the geometry we care about. So zone fills on. We have challenge number 9 on the internal layer. We've got power plane, I believe it is, on either sides of it. This is just constraints of, obviously I wouldn't normally run a differential pair through a power plane, but this isn't even really a differential pair. This is 2 single-ended tracks that are pretending to be a diff pair for the purposes of a challenge. I actually needed a power plane for the board to work correctly, and I stole a bunch of sections out of the power plane because nothing on this board is actually that fast, and I didn't want to make it 6 or 8 layers because the whole point is it's an expendable training board that you can go blow through a bunch of and fry several before you get things right. And so anyway, plan is going to be we're going to mill through this backside. The back layer has nothing on it, so it's relatively easy. We don't have to worry about reconnecting any other traces. We're going to go through, we're going to expose layer 3 from the underside. And once we get to this section, then it's going to be a manual, either scalpel or mill, I'll decide once I get it exposed, trace cut to break this. And then we got to solder from here to here and from here to here, reconnect it, and put everything back together. So yeah, that's the plan. I'm gonna go get this fixtured up on the mill and then probably take a 2-minute break just to get a sip of water because I've been talking for a while. But let's go get things fixtured first. And I'm also going to go take this lab coat off because I am getting pretty toasty in it, and I am not working with any UV for a while, so I should be good to take that off. So let's see, we're going to come from, let's think about fixturing angles. With the P mods, fixturing the board is going to be a little bit tricky. I might actually, I don't know if this is going to be secure enough to go like this. Only one way to find out. Alternatively, I may actually, we're only going down 1 layer. It might make more sense to rotate the board a bit. And if I go this way, that might give me a little bit more strength for clamping if I go like that. All the connectors make fixturing tricky, and again, this is a concern on Real Designs, is you may have a populated board that has a bunch of bulky stuff that's getting in the way when you're trying to fixture it for an interlayer edit. And so trying to figure out how to get everything positioned so that you've got easy access to the things that you're actually going to be doing the rework on. And now I just got to get my needle to clear. Okay, I may have to rearrange a few things because I've got my mill table is coming in further than I wanted. Okay, well, this is one of the real challenges of doing this sort of stuff. Let's just make sure I've got the, yep. Okay, so let's go, I'm just going to move the milling area over to where I'm going to work, and then if I have to go reposition the camera or, okay, yeah, so I can feel I am hitting the indicator stand that I have my gas needle mounted to, so I'm going to have to reposition that. Okay, what am I hitting here? Oh, I am hitting there's a cable that I'm going to have to take out of a cable management loop here. I forget which cable that is, but I was hitting it. Okay, so now I'm going to want to come like this. That will get the gas where it needs to be, and then move the light there. So now I can see what I'm doing. Get the mill head where it needs to be, and the gas is going to be coming from here, and adjust the position of the camera slightly. So, all right, so if I have the mill is going to be there, we want that to be roughly centered in the camera field of view, maybe a little above like that. That looks like about the right focus. And then we're going to want the gas coming a little bit lower of an angle, like that. That'll probably... Alright, I gotta get the... Alright, yeah, so the gas will come from a slightly steeper angle now. And that should be good. And we're going to be coming from here. And we're just going to try and mill probably almost the entire interior of that box, and get that whole area exposed down to layer 3. And then I can worry about the actual edit later on. In practice, if we were trying to do this a bit more conservatively, we could try doing a smaller aperture, but for training purposes, I want to see if I can do a good large area opening anyway and keep it nice and planar across the whole area and not have problems with like going too deep at one side and not deep enough on the other side or something like that. So I think I'm going to keep it like this. Why do I need gas? Purely for debris extraction. It does not strictly have to be nitrogen. Compressed air would work just as well. It doesn't have to be inert. However, I don't have a compressor, and I do have a nitrogen bottle left over from some other experiments, and the gas is cheap enough and I go through it slow enough that it's not worth buying a compressor just to do this. When I have a 20 cubic foot tank and I burn through like 50 psi of pressure for each circuit at it, it's, you know, the couple dollars of gas. Diameter of the end mill is 250 microns. So we're going to be opening an aperture that's actually fairly large by interlayer circuit edit standards, but relatively decent. Okay, so yeah, I think I'm at a good stopping point for the next couple of minutes. I'm just going to take the mic off real quick and grab a drink before I come back to the milling. And yeah, we're going to pick things up in 2-3 minutes and see how long it's going to take us to mill down to the traces for challenge number 9. All right, and we're back. And I somehow managed to get the mic cable twisted in a knot when I took it off. Let's turn the CAD view back on. The milling view here. So again, to recap, we've got this interlayer differential pair that we are trying to swap with a interlayer edit. Yes, this is a Showerline. It is a 5400. Currently, the mill itself is entirely stock. I've just got a lot of custom accessories mounted around it, like the microscope and the light and the camera and so on are all custom. So it gets pretty cramped around here. But yes, it is a Showerline 5400 and not modified currently. I am seriously considering upgrading the spindle at some point. The run out is worse than I would like, and the RPM is also a little bit lower than I would like, but it gets the job done. All right, let's go get our dust extraction gas on. Nitrogen tank open. And we're gonna go up to 3 PSI again. Increase, increase. And 3 PSI, that worked well last time. We'll stay with that. I need to get a more permanent dust collection system rather than shop vac on the floor that I'm trying not to trip over the cable for. But this is what I got right now, and this is what I got to work with. All right, so dust collection is on. Spindle on. We've got about 100-ish microns to go through. I think 100. Actually, I think Ospark 4 layer is closer to 200. All right, so first step is just going to be a really gentle, really light pass, just to check that everything is level. So we're just literally milling the silk screen right now. We're not even really into solder mask, and just making sure that we're planar. I gotta tweak the gas position a little bit. And make sure we're actually removing the chips. There we go, that's a lot better. See, now we don't have the chips mostly getting stuck on the surface anymore. They're mostly blown away. I always try and do, on a big rectangular edit like this, I always try and start from the edges and work my way in, because you don't have to be precise with your big motions when you're working in the middle space. You just have to worry about when you're working the edges. Maybe a little bit down a bit more. Over here. Down another 20-some microns. Make a quick pass. We know we're quite a ways above the copper. Like another 30 microns. Still looks like we're nowhere near it. I think I see the beginnings of the copper layer starting to come into view, so we're going to want to make lighter passes from here on out. Alright, yeah, we're definitely getting close. Let's go down like 20 microns. Alright, still not hitting copper. Another 10. Still not on copper. Another 10. Still not. Another 10. That's probably enough for another pass over the hollow area. I can definitely see the pair starting to come into view though. And I know we're not done, but just for the viewer's sake, what I'm going to do now is take a drop of IPA and just stick it in if I can get it in position around the camera and all the other components. Oh, right, the gas is in the way. I'm going to have to turn that off to make it work. All right. So turn the gas down for a second and get a drop of IPA right through there, and you should be able to see the copper much more clearly. So that's a little trick, just having the alcohol in the hole will match the refractive index of the glass to the resin a little bit better and give you a much better idea of how close you are to the surface. All right, so let's continue with the milling. Just wanted to show that real quick. Back up to 3 psi. And that should dry up our work area pretty quickly, just like I wanted. Suction on, spindle on. Go over to this side. We're going to do, again, probably 10 microns per pass now until we start seeing copper. You can probably be 50, 75 microns from a layer and still see it, especially with the alcohol technique. And so thicknesses can be deceiving sometimes. And this is absolutely a bigger opening than you would need to do this at it. Again, this is in practice. So notice now we're getting to the point we cannot see the mill surface on the bottom edge of the cut. And so this is one of the reasons why having longer or stepped cavities can be helpful for deeper edits. And you have to pay attention to the orientation of your mill cavity when you're doing a deeper edit. So in this case, having it oriented this axis is not really ideal because it means we don't have that visibility into the bottom of the cavity. However, with the connectors the way they are, this is a shallow enough edit that I felt comfortable doing it and knowing how much air we had around it. But it is a factor to keep in mind, because if you're doing something deep, you will likely have to step the cavity because the lip at the edge of the cut of the unremoved material will begin to block the view of the bottom. Especially from the angle that I'm looking at. I just realized the viewer's camera is coming off from the side, so you actually have better visibility into the bottom of the cavity than I do. My view coming in, I am looking pretty much perpendicular to the long axis of the cavity. At some point, I really want to set up a camera that can record through the microscope eyepiece to see what I'm seeing. It's just a little tricky with the geometry of the mill as it stands. Alright, so we are really close. I can see it just starting to break through on the right side. So we're in that adhesive layer. Another 10. So I think that is exposed metal. Yep, alright, one more pass just to clean up the traces, make sure everything is nice and smooth. Perfect, that is exactly what we wanted. And suction off. And gas off. Tank off. Alright, that looks like perfect result. I am going to need to move the mill axis a bit in order to get the board out though. I can't get my wrench on the vise like this, and huh. That's interesting. Did I just break my end mill? I think I broke the end mill. I must have banged it into a component or something. Well, that's annoying. I mean, they don't last forever, but I'm pretty sure that was me just being dumb. Yep, I absolutely broke the end mill. Alright, well, let's take a look at the board. Make sure I didn't damage whatever component I ran into. I thought I had lifted high enough to clear. Oof. Alright, well, I guess we have a little more rework to do. Going over to here, looks like I also chipped the cap that I crashed into. I thought I had lifted high enough. Oops. Alright, well, let me go load a new end mill up before I forget. And then we can continue with the regularly scheduled programming. So this was that is a 250 micron. I have another 5 of them. Alright, and that's that. And old mill is just going to go in the sharp spin. Alright, and that was a 4.7 microfarad cap that I busted. And yeah, that was probably a $25-ish mill. I don't remember exactly how much they go for. They're not super cheap, but maybe 25 to 50, I don't know. Enough that I'm annoyed, but it's not the end of the world. But yeah, that cap is pretty badly chipped. You can see here. I'm assuming it's internally shorted at this point, so I'm just going to preemptively replace it, and then we can move on to everything else. I lifted up the Z-axis. I thought I had gone far enough to clear, but apparently not. This kind of ties into a old rule of thumb that I've heard. I have no idea how accurate it is, but I believe it, that statistically much more glassware is broken during cleaning rather than during actual chemistry operations. And kind of the same thing applies. You let your guard down when you're done with the actual precision work, and that's when you screw up and break the tool. Let's see if I got that. It's still sitting high a little bit. I'm going to fix that later. I don't want to be hot airing in the vicinity of the edit when I've got bare uncoated copper in the area. Anyway, we know what we got to do to fix that. Let me put the reel of caps back away. And sorry, I already threw out the cap. If I had seen your message, I would have measured it, but yep, I'm not going to move to dig around in the garbage to find it. Yeah, if I'd seen your message earlier, I absolutely would have measured it. Alright, so let's go clean up some of the milling debris around this area, and then we can see about doing the actual interlayer edit here. And yes, I think it is very likely that it is internally shorted. I just don't have it easily accessible to measure, but it does not take much of a chip to cause a ceramic cap to short. So if I see any externally visible damage whatsoever, I'm going to preemptively replace it. Alright, so now we're ready to do the actual interlayer pair swap. So first step is going to be making a cut in the existing traces. So we're going to do that. And I'm going to swap again to the number 12 scalpel. I really like the 11s when I can, just because it fits my hand better. But the 12s are good for when you're trying to do these higher aspect ratio edits and you got to go kind of down into a cavity. You absolutely could do this with the mill as well if you wanted to, but I'm trying to show off different techniques here. All right, so that's the old tracks removed. Probably would have been easier to do that while I had it in the mill, but I wasn't sure I was going to have the clearance to do that, and visibility was not super great. And again, it's always nice to show off different techniques with different tools, so. And yeah, this is, I believe, a 400-point problem. There is a 5 that we're definitely not going to get to on today's stream. We're probably going to wrap this stream after I finish this one. This is not completely contrived, though. I have done this exact repair on a real board in the past. It was actually on, I believe, layer 6 of 10, so I had to go even further, and there was some stuff on the top layer that I had to bypass in order to get to it. So yeah, it's good to be able to practice before you have this sort of problem for real. Like, sure, the clearing shorts and other 100-point problems like we had at the beginning of the stream, sure, those are the more common things that need to be reworked, but half the point of this challenge is to push limits and work on the really difficult stuff, even if it's not necessarily the most common. Plus, if it was easy, it wouldn't be fun. All right, so we're back here, and I'm just trying to, I got a USB cable going to another board that I'm trying to work around. It's in a kind of an annoying spot, and the board keeps snagging on it, but I need JTAG to my customer's device working, and I don't really feel like unplugging it, so I'm just going to work around it. I also really need to go clean my syringe holder thingy here. If I, let's see, it's this camera you're looking at? Yeah. Looking back here, I've got this little 3D printed holder for my scalpels, and the scalpels sit in here, and they've got little ridged patterns that catch the hand grips. And so I've got holes for the various syringes of solvents and things like that, and the one for the flux always gums up over time, and yeah, I'm clearly overdue to go clean that. Anyway, so the first step is going to be get the ends of all these traces tinned, which should be easy because when they're milled, you get a really smooth, debris-free surface. All the oxidation is scratched off, and you've got good connections to everything. So we're gonna tin the end of that one and tin that one. All right, perfect. Yeah, see how easily they tin. As long as you haven't done any high temperature processing that's going to cause oxidation, the milled surfaces are beautifully easy to solder to. I'm actually going to switch to the fine tweezers again. They are more fragile, but for some of this work, you really do need that. So trying to get this trace to lie flat, we can clean up shorts later. But I don't want it sticking up. I think I need to get some of that extra solder out of the way before I do anything else. And again, this sort of really fine pitch, three-dimensional rework is not easy. If it was easy, everybody would be doing it all the time. And no, cutting short strips first is actually a bad idea. It makes things much easier to handle if you have kind of a tail to work with. What I'm just trying to do here is I want to get that exposed bit of power plane cleaned off. There we go. And everything gets sticky as soon as you start adding flux, which does not help. I think that should do. And then back to the other tweezers. These really fine ones are just challenging to grip. And I mean, just determining the angle of your workpiece and which tools you want to hold in which hands and how you want to positioning things, that's a whole art in itself. And I'm starting to oof. All right, I just lifted a piece of trace. That's it's at least tacked for the moment. I know it's not secure. But as soon as you have it at least slightly stuck in place, then what you can do is cut off the tail. We're going to keep that for the crossover trace. And then align that. And now the first end is loose, but that's easy enough to fix for some definition of easy. And so I find the work area again. And yes, steady hands are a must for this sort of thing. And that tiny little blob of solder is probably 100 times more than I need. More flux is never a bad thing. You end up doing like immersion soldering for some of this sort of stuff. Just not even necessarily because it gives better results, but because it is hard to not submerge the entire work area. All right, I think we're about where we want to be on this one. And constantly flipping the thing around so I can use the hand that I want to use for each tool. And yes, that is flat copper ribbon. Circuit Medic sells these as well. They call them circuit tracks. I'm sure there are other suppliers, but that's the brand that I use. And great, I've now welded my desoldering braid to the board, and I gotta get it off. Okay, well, I got the unwanted solder off and some of what I did want. The other thing is when you're doing this sort of really short track, fine pitch soldering, you need to be very careful about how fast you work. Normally, it doesn't matter as much how fast you work, but what you're trying to avoid doing is you don't want to conduct enough heat down the length of the track that you cause the other end to melt, because you're relying on that other end to hold your work in place. And yeah, so I need just a touch more solder in here, and I'm sure this is 100 times more than I need. All right. It's in place, it's sitting there, it does not appear to be shorted to anything. Alright, one down. Alright, let's go clean some of the flux out of here. And do a quick inspection, make sure that it's good. So to the newcomers, this is a interlayer differential pair swap. We've already milled down to it, destroying the end mill at the very end due to a silly screw up where I thought I was clear of tall components in the board afterwards, and as I was unmounting the board, banged the capacitor into it. And now we've got one leg of the diff pair crisscrossed over to the new location, and we're just cleaning some of the flux out of the way in preparation for moving forward. Alright, I think that's about as clean as we're going to get. So what I'm going to do now is try and get a bit of that UV cure solder mask onto the one trace and not the other one to hold it in place, and also to insulate it in the crossover period where the other leg of the pair is going to jump over it. So I'm going to get the lab coat on real quick. And get another of those little probe needles. And gloves. And yes, using a real mill makes so much better results for this sort of thing. All right, so we have the old batch of solder mask that we mixed up previously, and we're going to see if that is still good. It doesn't look like it's solidified at all. Now this is probably like picoliters of solder mask trying to get on here and cover and secure the one trace so it doesn't move around while not touching the one that we haven't soldered to yet. Got a little bit on the end there. That may actually be good because I think I lifted the tip of that trace. So I may actually want a little bit on the very tip, and I'll just solder to it a little further aft. Yeah, so we'll use that to tack that down. And then over here. All right, that looks cured. And yes, a good microscope is an absolute must. Mine is a Leica that was quite expensive. You can absolutely get away with less fancy. I was doing interlayer rework for quite some time with an Amscope, and the image quality was a little less good. The quality of life, it wasn't as good at being parfocal and everything. But yeah, I agree. I've soldered 0.1-inch headers under a microscope just because it's more ergonomic. I don't have to bend over and squint or anything like that. One of the upgrades I'm actually planning on doing for my lab soon is getting a different microscope body that has a larger zoom range and a lower magnification objective. The idea there is lower mag will let me work with bigger stuff and still be able to use the microscope, so I can be at 2-3x instead of, I think, 7.5 is my minimum magnification right now. It'll also give me larger field of view, longer working distance, allowing me to get more tools and stuff in under it and not be quite as cramped. And the one thing is I don't want to give up high mag, because like right now I'm a decent chunk of the way up my magnification range and I don't want to lose that. And so by getting a body that has a larger zoom range, I will maintain that high magnification capability while also getting low mag in addition to what I've got now. Alright, so we're done with the desoldering braid for the moment. Now we've got the other wire. Yeah, I do not like mantises. I've tried one once or twice at other people's labs, and yeah, it's not for me. The setup I'm running right now is a Leica M80. I am eyeing one of the higher end M series to replace it with more zoom range. The M80 is Leica's nicest microscope in the line that does not have a encoder on the zoom axis, meaning the software does not know what magnification you're at, so it won't auto adjust the scale bar. The M125 and up at it. And yeah, I mean, absolutely you can do small stuff without magnification. I've done 0.5mm QFP in a random office in Sham Shui Po, and absolutely not the proper equipment. Soldering iron that was probably like Radio Shack grade. Can't say I recommend it. I've done it. All right, I think we're good. Let's go clean everything up. Get the tools tidied up. And yeah, I mean, there are also degrees of microscopes. Like this one here, this is probably a $10,000 microscope. The Amscope I used when I started out was a few hundred. The one I got that was cheaper than the Amscope, I want to say was around $250. Now, admitted this was a long time ago, but you can get really cheap microscopes if you don't care all that much about image quality. As far as what size, yes, these are, I believe, 0.125 millimeter, both the tracks on the board and the repair tracks. Yeah, I wish I could have scale bars on here. Unfortunately, I am entirely Linux-based, and the Leica software that has the scale bar calibration and everything on it only runs on Windows. And I have it actually installed on one of my LaCroix oscilloscopes for day-to-day use in the lab, so I can take images and get scale bars and everything on them. I have so far not found a way to get that video feed onto my Linux machine that I can stream from. I would probably need to get like a video capture card plugged into the HDMI output of the microscope, because I tried RDP and it was too laggy for this sort of thing. The scope CPU did not have the oomph to do the real-time video encoding properly. So I'll have to go figure something out. Anyway, now I'm just trying to get some of the flux and debris out of the way to make really sure that everything is good. We'll actually probably do an electrical verification before recoding and filling the hole, just because I don't want to have to drill out a bunch of cured solder mask and stuff to come back in and resolder it. And yes, polarization is absolutely amazing. If you've never worked with a scope that had a polarizer before, I will demonstrate mine in a few seconds after I get this out of here. Alright, so I think that looks pretty good. I don't see any shorts. Everything looks like it's making good contact. If we switch over to the top view, just as people were asking about the polarizer here. So this is with the polarizer in the normal configuration, and then we can rotate it and we get that. And then looking at like some of the shiny surfaces here, for example, get the focus tweaked a little bit. They're all super shiny and then completely drop out when you have the polarizer at the best rejection. And all the laser markings become super duper easy to read. However, also like traces through solder mask can get hard to see. So depending on what you're looking for, you may, it's not like you always, also the image gets dim. So depending on what you're looking for, you may want one or the other. So let's just quickly go over to the verification view here and hook up, let's double check where did my phone go. Check the ordering of the signals again. It is white, blue, purple on the UART. White, blue, purple. get that connected, get the debugger connected, and that was challenge number 9 that we were just doing. Let's double check. Yeah, that was challenge number 9. So challenge number 9 is okay. We are now electrically correct. Now let's just go take everything apart and get everything cleaned and protected to make sure it'll stay that way. So we are done soldering. Iron and hot air can come off. All right, so let's just remount this, and we're gonna go and solder mask coat the whole area, do a couple of coats, and make really sure everything is not going to short or get disconnected in the future. I'm not going to bother filling the entire cavity. I just want to have everything coated and protected. So if the bottom of the cavity is fully sealed, if it's not flush with the top of the PCB, I don't care. If I was doing this in some application that actually cared about planarity of the top, I could, but like this is more than good enough for the purposes of protecting the rework. So get that all covered in. I think that should be it. Let's go zap it. I'm actually gonna reconfigure this real quick and see if I can hit it while it's under the microscope for you guys to see. Yeah, the angles don't really work out. I don't think I got a good illumination of the actual area, so I'm gonna have to pull it out here and just blast it. And I'm gonna hit it a couple of times just to make really sure, because this is a pretty thick layer. All right, and final visual inspection. No exposed metal, everything is covered, everything is sealed, the surface looks to be cured. I could do a second coat if I really wanted to, but we're going to be doing so much other interlayer edits, I can always go back and put another coat on later. And just checking one more time, make sure everything is electrically functional. And that's LED number 9 is on, so we're good. Which solder mask do I use? Some random thing from AliExpress or Amazon. I can't remember which. I I had some I got from a different supplier and it worked just as well. The one thing that bugs me is I have not been able to get an MSDS for it, so I have no idea what's in it. I am generally assuming it is full of nasty, uncured monomers that are super reactive and, you know, don't get it on your skin, ventilate the area, but it'd be nice if I at least knew for sure what was in it. I'm certain this is some commonly used, like, Shengyi or Taiyuan or something. You know, one of the big PCB material suppliers almost certainly makes it, and this is just some company on AliExpress that is repackaging it in small quantities for overseas and small volume user sales. But since they haven't told me which it is, it's not really too useful to me. So yeah, if I can get in touch with the seller at some point and get an MSDS for it, that would be great. So far, I have not been successful at getting a response. There's like a dozen people selling what's clearly the same kit, and I have no idea which one of them, if any, is the original rebottler and how many of the others are just buying the pre-sealed packs from this one source. So anyway, I think that is going to be it for today. It's been 3 hours and I need to have some lunch and get back to work. But yeah, we banged through challenges 1 through 9, which is pretty good. Coming up afterwards, in the next couple of days, whenever I get around to continuing, number 10 is a missing via between front and back. Number 11 is a via from front to back that is shorted to a zone fill, and we have to clear the short to the inner layer while preserving the front to back connection. 12 is 2 balls on the edge of the BGA are making bad contact due to a bad solder paste print, aka I didn't put solder paste on those pads in the stencil. So for that, it's just going to be squirt some flux under and reflow the BGA and hope that it connects. Number 13 we already did. That was the bad BGA trace that we did before stuffing the board. Number 14 is going to be the backside milling to hit the BGA pad from the underside. Then 15 is, I think, a super easy one. I just added it late. Yeah, 15 is just a missing pull-up on a trace. There's just no footprint for it. And 16 is a via under the BGA that is strapping to the power plane and should connect to the ground plane. So a bunch of fun, high-end inner layer rework, and then a couple of easy ones in and around all of that. So yeah, thanks for watching, and I'll be back sometime in the next couple days. We'll see.